A while back, I made a manga panel splitter, an experiment, a proof of concept, using those YOLO, you only look once models, with the idea of making a manga reader. I will simply show you how I went about making this proof of concept. If you've ever seen a YouTube video reading out manga chapters, panels, usually these panels slide into the frame and they are being read out loud in the correct order. So there's a few challenges there. As one would be to split those manga panels so that we can show them one by one, or at least show the first section and then the next section. But then also, if you have panels ordered like this, you need to make sure, yeah, to sort them correctly and read them in the correct order. To read them, of course, you need to extract the text from those panels. So that would be by using an OCR technique, so optical character recognition. And I would leverage an open source model for that, either Doctor or a Microsoft Transformer model. In between, we could put a model to detect speech bubbles, text bubbles, but as you can see, not all text is in a text bubble. So yeah, and then the nature of these panels, sometimes the balloons pop out of the frame. So instead of object detection or bounding box detection, what I applied here, we could have maybe gone for segmentation, which would be able to capture more complex objects more precisely. But first things first, what I do first is look for techniques. Methods doesn't have to be machine learning or deep learning per se. That perhaps can solve the problem. So like this canny edge detection is an OpenCV computer vision technique, which is basically doing all kinds of image transformations, blurring the lines and so on, to then try to segment, maybe based on pixel color, try to segment the panels. As you can see, you may only get a horizontal split, not the individual panels. And it can't handle complexer panels, and well, the result is not that great, just one thing. So yeah, there's a few different things you can try. Also, maybe pre-trained models or yeah, things like that. Segment anything, manga OCR, speech bubble detection, all just experimentation. I will likely put this project on my Patreon, so make sure to check that out. After trying all that, of course, I look into a machine learning or deep learning technique and, well, and existing examples, of course. For this one, because those techniques, those deep learning models, they need a lot of data if you need to retrain them. So first, of course, you look for a pre-trained one. If that doesn't work out too well, then we need to find a way to retrain those models based on our, well, the task we wanted to do. So instead of detecting people in an image, we'd want to detect manga panels. So I basically just did a Google search looking for datasets. So machine learning and deep learning problems often start with datasets, dataset manga panels. And then I found some segmentation. I found some, of course. But more specifically, I found a lot on RoboFlow. I think I can even say, let's make it for YOLO V8. And then you can just simply download these images, these datasets. And when you download them, it is possible that you can select for which model you want to train with it. So specifically export it to be in the format to train with a YOLO model. Could be V8, V9, V10. Or you could start making your own datasets by using their data labeling tools, for example. Of course, you don't need to use RoboFlow, just came up on my Google search, and then that results in some kind of, let's see, this data, and then you basically have a data.yaml in which you specify where to look for the training data, the validation data, the test data, the labels, and some metadata. If we then look into those training data, we'll find images, labels. I will talk about what that means later. Images is basically the ones we'd want to start to recognize, but you see some duplicates, and that's basically the same image but slightly tilted. That's a way to augment the data to make a machine learning model more robust, so it doesn't fail on a slightly tilted image or a slightly varying image. Okay, and that's basically all for that. And then you can often find the models itself on the ultralytics.com website. So to start from certain model, a model that is able to do object detection or segmentation on more common objects. Okay. And then you can likely also find the code to easily use this model to predict with these models, or to retrain these models, and even to export these models. So then I go back to my Jupyter notebook. I make sure I'm using my GPU, using CUDA. This code is commented out is to export it to an ONNX format. We'll do that later. First, of course, we need to train the model. So I started with a base model of Ultralytics, v8n.pt. Then I referenced that path, which specifies where to look for the training data, the test data, the validation data, and so on. And then I simply train the model. These epochs, we're basically doing like 100 cycles. 100 times it's going to take a batch of data to train on. I will explain all of that in detail, maybe in more basic videos. Let me show you what that outputs. Models and results. First, it's my last one. The train 2 consists of those actual visual predictions. So that looks pretty good. Here as well, it's kind of trying to contain the entire thing, which is pretty good, but with segmentation, maybe we can make this more accurate, I assume. But I couldn't find too many data sets that were labeled for segmentation. It's slightly different, and as a proof of concept, I didn't want to go ahead and do all that myself. That's quite some work. Here it's detecting the background as a panel, which is incorrect. But then it's also detecting the actual panels as panels, which is good. This one's okay. This one, the same problem. It's kind of making 3 boxes instead of 2. Okay. Sometimes it depends on the white space around your panels, the padding, the cropping, the zoom level, whatever, to make it easier to detect the panels. Anyhow, then in the train folder, you've got some metrics. So confusion matrix on the testing or on the validation, I assume the testing. And then it's basically predicting 223 times manga panel, which is correct. And then 14 mistakes. So it predicted manga panel when it was a background, and vice versa. So basically, yeah. There's more metrics. Many of those models have their own set of metrics, or similar ones. It's a matter of learning to interpret these. Precision confidence curve looks a bit better. And then this, I find it's basically, as the model training progresses, the error rate goes down. So that means the model is performing quite well. Training. And then validation. This validation set is also data that the model hasn't seen yet. So while then showing these, trying to predict on these unseen panels, we then get to see how the model performs. So that all looks pretty decent. Does make a few mistakes, but okay, that was not really in depth, but we'll get to that later on. I'll likely give a back to the basics of machine learning course. Well, not really a course, just a few YouTube videos. But by now, this space is so large that I'm not sure if we'll ever catch up with it, but I'll give it a go anyway. Okay, so then we have a decently trained model. Then I exported it to ONNX so I can easily use it in my .NET applications. So basically this ONNX model, then using, let's see, using CompuNet's YOLO Sharp NuGet package to do the detections and even to plot the bounding boxes on there. But this is just a background worker service, which is going to take in a PDF with a PDF of the manga, all the pages, and it's going to split each page into images and each image into panels, and then export those panels, and it would look like, let's see. These are just the pages, and then let's see if we can see a prediction. It's basically with the plotted thing on there. Yeah, and here it was pretty difficult to sort the panels in the correct order to show after splitting them. So yeah, quite a few challenges there, but all looks pretty decent. Here as well, to make sure the panels after splitting, I can reconstruct them, show them again in the correct order. That's yeah. Okay. What's this panels? Oh, this is after cropping the panels. Maybe aligning them differently. Let's see. Anyway, quite a fun project to work with. I really like doing those things. It does take quite some time to even get a proof of concept to figure out which techniques to continue with. But the result is quite powerful. This is, of course, just splitting manga panels, but there's some real business use cases for that, for using the same techniques. Yeah, processing other types of documents. So really cool stuff. Okay, so I think that was all for this video. I just wanted to show you something I worked on recently, combining Python, machine learning, well, deep learning, AI, some existing powerful models like YOLO, retraining them on a custom data set that you can find online or make yourself, and then yeah, trying to solve the well the problem. But oftentimes you gotta combine multiple models. For example, there was one for splitting the panels, then there may be one for to detect the speech bubbles, or just one to read out the text, so to transform the text into extract the text from the image, and then maybe another model to read it out to text to speech, something like that. Anyway, I'll drop this on my Patreon channel, so make sure to check out the code there. Of course, I'm not gonna drop all of the imagery and all of the models and everything, since it's quite heavy. Mostly just the code to get those. And if you're missing a few steps, you can't make this work, do check out my YOLO V8 video, in which I show you how to set up a virtual environment in Python, how to install these Jupyter notebooks and run them so you can execute this Python code. If you want some of my original code behind my NuGet packages to check out my kisco.com/products and the products, the source code of the product. If you're interested, I know it's not a typical video that I do, but if you got any value out of this, do let me know. Leave a like, subscribe. If you have a business problem that you want to tackle with AI, with deep learning, machine learning, or other techniques, do reach out. You can just hire me. Well, especially if you want to combine .NET and Python, or just Python, just .NET. That's all good. See you in the next one.